Welcome to another physics practical walkthrough from Godalming College Physics Department. Today we're going to be looking at the G by Freefall experiment. It's quite a complex setup, there's lots of tricky measurements to make, but if you do this experiment well, you will get a really good value for G. This gives you an excellent opportunity to do a full analysis, lots of uncertainties, lots of comparisons with theoretical data. So this is the perfect experiment to practice all the skills that you've already learnt. As always, in this experiment we'll give you a script, and crucially you are going to have to follow instructions. Also going to want to see that you set it all up yourself and are able to tabulate and process the results properly. For this experiment we give you all of the equipment, with the majority of it being set in a single blue tray that you'll be able to access. You will have to go and get a scalar timer from the far end of the lab. Here is all the equipment laid out. Here's where you'll be able to find the blue tray. The premise of the experiment is that when we release a steel ball, it will start a timer. It will drop a distance h that we're going to measure, and it's going to hit a trapdoor, and that trapdoor will stop a timer. Therefore we've got the time, we've got h, so we can calculate g using an equation of motion. Clearly you're not just going to do this once, so you're going to perform this for several values of h, and because it's a time, you're going to repeat it. Here's an example of the table, and here's a quick whiz through the different analysis you're going to do to make sure that you've got a good idea of the uncertainties for your measurement. Okay, let's set this up. So you've got to set it up off the side of the bench, mainly because we want to try and get a full range of values. Starting at say 30 centimetres, going up all the way to a metre. None of our clamp stands are tall enough, so you can have to set it up with the trapdoor sitting on a stool off the side of the bench. Probably the first thing to do is make sure you set up a couple of clamps, one for that release mechanism and one for the meter ruler. Then put the trapdoor box off the side of the bench and just do a couple of releases to make sure that the ball is actually going to hit the trapdoor. You want it to hit in a consistent place, so use the non-slip mat so it doesn't move. Once you've got the trapdoor and the release mechanism all set up nicely, you then need to connect the cables. The way you do this is by looking at this sheet. It explains what settings and where to place the cables. There are about 3 different types of scalar timer. One set of cables will short out start, the other ones will short out stop. To test it, before you even actually start the experiment, just do a few quick runs to make sure that the timer does start and stop when you release the ball. After that, get the meter rule set up. Okay, let's have a look at this from the other angle. You can see the trapdoor sitting on a stool with the meter ruler and the release mechanism above it. The release mechanism is at roughly 30 centimetres. With the ball bearing, we're going to check in a moment at a specific height. The ruler is sitting, so the bottom of the ruler is just at the top of the face of the trapdoor, and we're going to use a set square to make sure that we know exactly what height, ideally 30 centimetres, the bottom of the ball bearing is sitting. All the wires are tucked out of the way. We've checked the meter ruler is square vertically in both planes. Right, let's run through how you're actually going to take the measurements. Each time you release the ball, you see it drop a distance and the scalar timer will make a time for that drop. You then fish it out, close the trapdoor. If you replace the ball bearing first, it will stop the timer going mental. Release it, you get another time. I would have it so that one person does this each time, making sure that they place that ball bearing in exactly the same place every time. Hopefully you'll get 3 readings roughly the same. One of you can be recording this in the table and even calculating t-square values, while the other person is taking the result and moving it up to different heights. Crucially, you mustn't move the position of the trapdoor in relation to the release mechanism, because that will give you an error that you can't really account for later on. Once you have taken the 30 centimetres. Then probably want to move it up, let's say 10 centimetres, take another value, and make sure you're taking 3 values for t for each of those heights. As I said, one of you can be calculating an average from those 3 and then calculate t squared. Just keep an eye out. If one of those values for t is bonkersly different, maybe you just need to rerun that. That's not good experimental practice generally, but on a standard experiment like this, it's good for you just to keep an eye out for really, really way out values. Once you've got 8 values, you can then go and process a graph, and we're asking you to look at the values for h and the values for t squared and think about whether they should need to go on the y or the x-axis of the graph. That way, when you process this, you'll be able to get a value for g. I hope you found this video useful. I hope you enjoy the experiment and that you develop your skills through it. And I'll see you in labs.